Myself, Dr. R. Kavitha, Assistant Professor of Chemistry, Shri Sharada College for Women, Salem. So now I am going to discuss the topic catalysis for a third BSc Chemistry program. This topic is in the module 4 of Physical Chemistry 1 paper in semester 5. Catalysis is a fundamental concept in chemistry and plays a pivotal role in various chemical processes from industrial manufacturing to biological reactions. So in this lecture, we will explore the basis of catalysis, its important types and some real-world examples. Let us see what is catalysis. The catalyst is a substance that alters the rate of the chemical reactions, but itself remains chemically unchanged at the end of the reaction. So here, any substance, if it alters the rate of the chemical reaction, so here alter means it may either increase the rate of the reaction or it may decrease the rate of the reaction. And at the end of the reaction, it remains chemically unchanged in its mass and its concentration. So then that substance is called as a catalyst. So now the whole process is called as catalysis. If the catalyst which enhances the rate of the reaction, then it is called positive catalyst and the process is known as positive catalysis. In the same way, the catalyst which retard the rate of a reaction, retard means it decreases the rate of a reaction, then the substance is called as negative catalyst and the process is known as negative catalysis. Okay, so here the substance either it increase the rate of the chemical reaction or decrease the rate of the chemical reaction. Okay, so then what is the basis of this catalysis? How does the catalyst increase the rate of the reaction or how does the catalyst decrease the rate of the reaction? As we know, here the catalyst, the basis of the catalysis is the catalyst lower the activation energy of a reaction by providing a new pathway. So here it do two actions. The one is it lower the activation energy. In the same way, it provide, that is by providing a new pathway. So you look at this diagram. So here the reactants, so it is that x-axis time and y-axis it is relative amount of energy in molecules. So here the reactant is converted into a product. The first one is about without catalyst. The first one is about without catalyst. So here the reactant have to cross this energy barrier and then it convert into a product. By means of with catalyst, it gives a different pathway to reach the product. So that is, you look at this, that is in terms of potential energy versus reaction progress. Here the reactant is in a higher energy, the product in a lower energy. So here that energy gap between the reactant and the activated complex is called as activation energy. That is, the activation energy is the minimum amount of energy required to cause the chemical reaction is known as activation energy. So in terms of uncatalyzed reaction, that EA, the activation energy is higher than that catalyst reaction. So by the way, it lower the activation energy of a reaction. Okay, then what are the types of catalysts? So there are two main types of catalysis. The first one is homogeneous catalysis and second one is heterogeneous catalysis. And the third type is the catalysis is known as the enzyme catalysis, which is largely of biological interest. So we will discuss this enzyme catalysis separately at the later stage. Okay, then what is homogeneous catalysis? So homogeneous, as we all know, Here both catalyst and the reactant and products are in the same phase, either in a gaseous phase or in a liquid phase. In the case of heterogeneous catalysis, here the reaction involves multi-phases. The reaction involves in multi-phases. That is, the catalyst and the reactant and products are in a different phase. Okay, let us see in detail about the homogeneous catalysis. A catalyst is in the same phase as the reactant and is evenly distributed throughout. Okay, so usually this type of catalysis is occur in a gaseous phase or in a liquid phase. Let us see some examples for a homogeneous catalysis. The first one is, that is, oxidation of sulfur dioxide to sulfur trioxide with nitric oxide as a catalyst. So you look at this reaction, that reactants sulfur dioxide and oxygen and the product are in a gaseous phase, and similarly that your catalyst also in a gaseous phase. The next example is the decomposition of acetaldehyde with iodine as a catalyst. So here acetaldehyde is in a vapor phase, your product methane in a gaseous phase, iodine is also in a vapor phase. So that is, the catalyst is in the same phase as the reactants. Okay, in both the case, the catalyst is in the same phase as the reactant. So these two are a very good examples for homogeneous catalysis. And so in the same way, we'll discuss some examples for a homogeneous catalysis in solution phase. The first one is, here the hydrolysis of cane sugar in aqueous solutions in the presence of mineral acids as a catalyst. So here look at this, all the reactant, products and your catalyst are in a same phase, that is in solution phase. And another one example, the hydrolysis of ester in the presence of either acid or alkali. Another one example, that is decomposition of hydrogen peroxides in the presence of iodide ion as a catalyst. So as you know that many of the reactions in a solution phase are catalyzed either by acids or by an base. So the homogeneous catalysis can take place either in a gaseous phase or in a solution phase. Now, next we are going to discuss about the heterogeneous catalysis in detail. Heterogeneous catalyst. So here the catalyst is in a different physical phase from the reactants. It is termed as a heterogeneous catalysis. So here sometimes this process is also called as contact catalysis. This process is also called as contact catalysis. Since the reactions occurs by a contact of reactants with the catalyst. So you look at this diagram. So here it is that array of catalyst is present, a gauze of catalyst, and in which the reactant molecules, it just sit on the surface of the catalyst. So this reaction, this process is called as contact catalysis, just by contact of reactants with the catalyst surface. So usually in contact catalysis, the catalyst is taken as a finely divided metal or in the form of gauze. So this form of catalyst has a great industrial importance. So let us see some examples. The first one is the combination of sulfur dioxide and oxygen to sulfur trioxides in the presence of platinum, finely divided platinum. The presence of finely divided platinum. Another one example, that nitrogen and hydrogen. So here that reaction, it is nothing but it is a Haber process. So here the reaction is catalyzed by the finely divided ion. And third type of catalyst, so here ammonia reacting with oxygen, it gives, that is, oxidation of ammonia to nitric oxide in the presence of platinum gauze. And the last one is here the hydrogenation reactions of, that's unsaturated organic compounds, which is catalyzed by the finely divided nickel. So in this heterogeneous catalysis, the catalyst is taken in the form of finely divided metal or a gas. Okay, the next one is promoters. A substance which though itself is not a catalyst, but it promotes the activity of the catalyst. These substances are called as promoters. So here just the activity of the catalyst is enhanced. Activity of the catalyst is enhanced by adding a small amount of the second material. The second substance is either not a catalyst itself, but it just feeble catalyst. It just promote the activity of the catalyst. So you look at the examples that Haber synthesis for the manufacture of ammonia. So as we already discussed, this reaction is catalyzed by the finely divided ion. Thus in the same way that activity of ion is promoted by the presence of molybdenum. And in the second reaction, that is carbon monoxide plus hydrogen gives methanol. So here it is catalyzed by zinc oxide, and the catalytic activity of the zinc oxide is promoted by the presence of chromium oxide. In sometimes this catalyst is used in addition with the promoters. That is, the mixture of catalysts are used to obtain the maximum catalytic efficiency. Okay. In what way these promoters change the activity of the catalyst? That is, it promote the activity of the catalyst. It do the two actions. The first one is it change of lattice spacing. Change of lattice spacing. So here that is the molybdenum. So in the Haber process, that catalyzed by the molybdenum. So here the molybdenum is present between the nickel array, so that the covalently bond of that hydrogen is much weakened and it cleaves readily, isn't it? So that is, here it just increase the distance between the catalyst particles. So this is the first way. By this way, the promoter promote the activity of the catalyst. And second thing is, it increase the peaks and cracks. That is, the presence of promoters increase the peaks and cracks on the catalyst surface. So this increase the concentration of the reactant molecules, and hence the rate of the reaction is also increases. So this is the common feature in a heterogeneous catalysis. Another important term is called as catalytic poisoning. So here, in the previous slide, we discussed promoters. It promotes the activity of the catalyst. But here, it is a catalytic poisoning. That is, it just destroys the activity of the catalyst. It's called as a poison. And this process is called catalytic poisoning. So for this, we have examples. It is oxidation of sulfur dioxide to sulfur trioxide is catalyzed by platinum. But the reaction is poisoned by the small amount of arsenic oxide. Another second one is the Haber process. In the Haber process, this presence of the hydrogen sulfide poison the whole reaction. And in third one is, in that reaction between the hydrogen and oxygen gives water. It is catalyzed by platinum, but it is poisoned by the presence of carbon monoxide. Okay, so in what way this substance which destroy the activity of the catalyst? Either sometimes it absorb on the catalyst surface in preference to the reactant, or it sometimes reacting with the catalyst and produce some new chemical compounds. So let us see. is, look at this diagram. So here the platinum metal array, the catalyst is there. So here before the reactant which will absorb on the surface of the platinum, here the carbon monoxide is absorbed on the catalyst surface in preference to the reactant. So by the way, it poisons the activity of the catalyst. And second action is, here the catalyst either it may combine chemically with the impurity. So for example, the Haber process is catalyzed by the presence of iron. It is poisoned by the presence of hydrogen sulfide. So here this hydrogen sulfide combined with the catalyst iron and it produces iron sulfide. So by which the activity of the catalyst is totally lost. So another thing is autocatalysis. So here the one of the product of the reaction itself that act as a catalyst for the reaction. So this is called as autocatalysis. As you see this, so here that graph between the percentage reaction and the time. So for a small, it is around a very minute teeny time. So there is no changes in the reaction. But after it reaches a certain time, again this progress of the reaction, the percentage of the reaction is increases. It follows a sigmoidal curve. That is, this time is required for the formation of the product. Then after that product formation, that product itself acts as a catalyst and it catalyzes the reaction. So for this, the very good example is arsenic hydride. There is a decomposition of arsen. So here the free arsenic produced by the decomposition of arsen, it just auto-catalyzes the reaction. So in this curve, that the maximum is obtained, that is when the reaction is complete. Another important terminology is negative catalysis. So here in that negative catalyst, that is the substance, that is a catalyst, reduce the rate of the reaction is called as a negative catalyst. Otherwise it is called as inhibitor. So here this phenomenon is called as either called inhibition or negative catalysis. So here that either the mechanism of the negative catalysis is different for different reactions. So for example, the trace of alkali which is dissolved from the glass of the container, which catalyzed the decomposition of the hydrogen peroxides. But the addition of acid will destroy that alkali catalyst and this prevent the decomposition. So another thing is over here, that oxidation of trichloromethane, that is chloroform, by the presence of oxygen. It is usually the chloroform is used as an anesthetic. Upon oxidation, it forms carbonyl chloride, but it is a highly poisonous substance. So how to avoid that formation of the poisonous substance? So we just add the 2% of ethanol. When it is added to the chloroform, it acts as a negative catalyst and it suppresses the formation of carbon chloride. So and another thing is, it just poisoning a catalyst by breaking a chain reaction. Okay, so but this mechanism is not same for all kinds of reactions. So for the mechanism is different for different reactions. So far we have discussed about that introduction of the catalysis, that is its definitions and its importance and its types and mechanisms. Okay students, if you have any specific questions or if you need any further clarification in the topic catalysis, you can feel free to contact me. Thank you.